The quadratic formula is a way that you can find the x-intercepts of a parabola. We've already talked about solving by factoring, which is a different way of finding x-intercepts, but the quadratic formula works for quadratics that have decimals, that have solutions that you can't get by factoring, or ones where you have really large numbers that you just wouldn't want to factor with. So I'm just going to fill in here that the quadratic formula is used to find the x-intercepts of a parabola. Now, sometimes they're called other things. You may see solutions, roots, or sometimes even zeros. If you're coming from French immersion, they also would have been called racines, if that helps you out. So the quadratic formula looks a little complicated until you get the hang of it. So it's x equals negative b plus or minus, and we'll talk about that in a second, the square root of b squared minus 4 times a times c, all divided by 2a. Now, a, b, and c are the coefficients of different parts of your quadratic. So the a is always the number in front of the x squared, b is the number in front of the x, and c is the number that doesn't have an x with it. It's called the constant. So one of the ways that I remember the quadratic formula is using a song, and it helps if you sing along. So if I sing a line, then you sing it back. It's an easy way to remember the formula. So we have negative b plus or minus square root b squared minus 4ac over 2a. Now, if you didn't sing along, you really should rewind that and try again and sing where the blank space was. It really does help to learn the formula. So we're going to try 2 examples. It says solve each of the following, and our first one here is 0 equals 3x squared plus 6x minus 10. So the first thing I want to do is I want to take a look at it and figure out what the a, the b, and the c are. So a is always going to be that number in front of the x squared, so it's 3. B is going to be the number in front of the x, which is 6. And c is going to be the number without the x, which is my negative 10. So I'm going to write down my formula. So negative b plus or minus square root b squared minus 4ac over 2a. And then what I'm going to do is substitute in all my numbers. So b is 6, so it's going to be negative 6 plus or minus the square root of b, so 6 squared, minus 4 times a, which is 3, times c, which is negative 10. And that is all divided by 2 times a, which is 3. So what I'm going to do in the next step is I'm going to evaluate what's underneath the square root. You could split it up into a couple of different steps, but I like to just do it all at once on my calculator. And I'm also going to multiply out the 2 times 3 on this step. So I have negative 6 plus or minus, and then on my calculator, I'm going to do 6 squared minus 4 times 3 times negative 10. You want to make sure that you hit equals on that to get the 156. And then 2 times 3 is just 6. Now, the square root of 156 is not a very nice number, and I really would not want to have to keep writing that decimal down all the time. So there's 2 types of answers we can get in this question. One of them is something called an exact answer, and one of them is called an approximate answer. And you're probably more familiar with the one that is the approximate answer, so I think that's the one that we will do first. An approximate answer is one that you get that has decimals that need to be rounded. So I'm actually going to get that by working this out on my calculator. Now, because I have the plus and minus is there to give me 2 different answers. Quadratic can have up to 2 x-intercepts. So the formula really needs to have that plus and minus to give me two different answers, to get me the two different answers that I'm looking for. So I'm going to split this up at this point into negative 6 plus the square root of 156 over 6, and x equals negative 6 minus the square root of 156 over 6. And then I'm going to use my calculator to work this out. So negative 6 plus the square root of 156. Now, really important, you want to hit equals before you divide. So we're going to hit equals and then divide by 6 on the bottom to get 1.08166599999. I usually like two numbers after the decimal place, so I'm going to keep the 0, the 8. The next number is a 1, which means I'm just going to leave it as 0 and 8. So I get 1.08 is my rounded value. And to show that I rounded, we do put a little dot there, just to let you know and me know that we rounded our number. Okay, and then this one here, same thing. We're going to do it again, except this time we're going to subtract. So negative 6 minus the square root of 156 equals, don't forget equals, and then divide by 6. And I get negative 3.081665999. So once again, I'm going to keep two digits after the decimal. The next one's a 1, so it's going to stay as 0.8. So I get negative 3.08, and because I rounded, I put the little dot over top of the equal sign. Now these are called approximate answers because that's what it's approximately equal to. When you round, you are losing some of the decimal places and a little bit of the precision. So it is not an exact answer, it is just approximate. An exact answer would be what we would get if we had left these alone. So I'm actually going to then look at the exact answers, and I still want to leave some space over here for your foldable in case you're filling that out. And what I'm going to do is I'm going to just write a little bit of what it would look like if I found my exact answer. So for the exact answer, I'm actually going to go back to the one with the plus and minus so that I don't have to keep writing this down twice. Since I know that my answer works out to be a decimal, an exact answer means I can't work out that square root. The square root is what's giving us the decimal. So I could just leave it like this, and that would be an exact answer, but we're in grade 11 now, and we can do a little bit better. So we're going to use something we just talked about, which is how to write the 156 as a mixed radical. So if you remember, the mixed radical is where you have a number out front, and what we want to do is look for the largest perfect square we can find that divides into 156. And I'm just going to do that up here in a little bit of spare space. So 156, I notice that it is an even number. So I'm going to try some of the larger even perfect squares and see if they go in. So 156, I could try 64. Nope. I can try 36. Nope. I can try 16. Nope. And then I can try 4. And if 4 doesn't work, we're kind of out of luck here. Oh, if I go back, I get 4. And I had through 39 before I hit equals twice. So I'm going to say that this is the square root of 4 times the square root of 39. Now the square root of 4 is 2, and the square root of 39 is not a very nice number if we try it. I get a decimal. So I'm just going to leave 2 root 39. So I'm going to take out the 156, and in its place we're going to put in 2 root 39. So negative 6 plus or minus 2 times the square root of 39 over 6. Now I'm going to do something a little strange here. I notice when I look at the numerator, the 6 and the 2 are both even numbers. So what I'm going to do is I'm going to factor a 2 out of the numerator. If I take a 2 out, 6 divided by 2 is negative 3. plus or minus 2 divided by 2 is 1. You can put the 1 in, it's up to you. And then the square root of 39, we don't try to divide that by 2. We treat it like it's an x or a y or some type of variable. And then I notice that on the top we're multiplying by 2, and on the bottom we're dividing by 6, and 6 is actually also divisible by 2. So what I'm going to do is I'm going to divide the top and the bottom by 2 to see if I can simplify that a little bit. And I get x equals, well, 2 divided by 2 is 1, so I'm not going to write the 1 in front. I'm just going to say it's negative 3 plus or minus the square root of 39. And 6 divided by 2 is 3. Now I see that I have a 3 on the top and a 3 on the bottom, but I don't have a 3 that I can factor out. You can only do this if it's something that you've factored out. Okay, I can't divide out unless it goes into everything. And I do see that 39 divides by 3, but it's underneath that square root, so I can't touch it. So this would be my simplified exact answer. Negative 3 plus or minus the square root of 39 over 3. You could write it as the two separate, the one with the plus and the one with the minus, but I'm okay with you writing it just as the plus and minus. Now the next question is also another quadratic, so 0 equals x squared minus 10x plus 35. So I'm going to start by writing down my a, b, and c. So a equals, well, if you don't see a coefficient, there's always a 1 hiding in front there, so a would be 1. B is not just 10, it's negative 10. You need to take the sign that comes with it. And then c would be 35. And you should always write down your formula. So x equals negative b plus or minus square root b squared minus 4ac divided by 2a. Hey! So negative b, this time we have negative 10. A negative makes a positive, so it actually ends up being positive 10 plus or minus the square root of. Now, it's negative 10, so it does need to go in brackets. It'll help you with your calculator before you square it. Minus 4 times a, which is 1, times c, which is 35. And then that is all divided by 2 times 1. So I have 10 plus or minus, and I'm going to calculate this part on my calculator. So I have 10 squared minus 4 times 1 times 35. And I ended up with negative 40. So if I get a negative, I usually check just one more time to make sure that I did it right. So this time I'm actually going to put the brackets in just to be sure. So bracket, and then negative 10, close bracket, squared, minus 4 times 1 times 35. And I got negative 40 again. 2 times 1 is 2. Now, the thing about negative 40 is when I take the square root of negative 40, I get an error. You can't take the square root of a negative number. It just doesn't work. So here, I cannot go any further because there is no solution. I'm getting an error. When something has no solution, that means that it has no x-intercepts, and if you were to look at the graph, it would probably be floating up above the x-axis, or it might be down below the x-axis, but either way, it's not going to cross the x-axis. It's not going to have any x-intercepts. So here we're going to say that it has no solution. We really have no real solutions. There are these things called imaginary numbers that are all about the negative square roots, but we're not going to talk about that until grade 12. So for now, we're just going to say that this has no solution. There are no x-intercepts, and that's that.